Hello and welcome back to another quick maths tutorial. In today's video I'll be talking about binomial distribution. This is following on in our binomial theorem series, and I've decided to do this for a few topics and before a few other probability topics I should have covered before, but I felt that since I'm doing this series I may as well cover it now, and I can overlap some of the things I talk about in probability theory, which by the way is my favorite area of maths. So I will be going over some of the things in this video, in other videos as well, just in case you don't watch them all. But I thought it's good to start off with this. So what we say here is the notation I have here. It's going to be quite new, all of it, but what it means is that this capital X, no, it's capital, we'll be using lowercase soon. Now the tilde means follows, and then this means a binomial distribution, which I'll talk about what a distribution is in a bit because I know that's going to be new to a lot of people. Of NMP. So a probability distribution is basically when you have certain outcomes and it's just looking at which ones are more likely than others and how you can sort of model that by taking into account things. So a binomial is a specific one, and as you know it's got bi in it, so it usually means two things, and this one doesn't really look at the different types of outcomes like and compares them in value. Like for example, I'll be looking at Poisson, that will. This just looks at either something happening or not happening. So there's the two outcomes: either something happens or it doesn't. We technically refer to these, and this will be the technical definition, as being a successful or a successful outcome or a failure, so an unsuccessful outcome. So those are the two things, essentially, what happens. And what you can do is you can view one outcome of something, like rolling a die. I'll be using that example in a bit. So let's say a normal die has 6 faces. Let's say it's unbiased. So that's going to be some big terminology. If something's unbiased, it means all its outcomes have an equal chance of happening, so their probabilities are the same. So you should know that a die has 6 sides. So if it's unbiased, each of the numbers 1 to 6 have a probability of 1 to 6. And that's what P stands for here, if you can read the definition. P is probability of your successful outcome. N is the number of trials. So what that means is if you were to try something like rolling a dice, picking a card out of a pack, or basically whatever you're doing, like that has an outcome, N is the amount of times you're doing it in a row. And what capital X is basically that's your discrete random variable, so it has to take on certain values, and it's basically asking how many out of them n times do you get a successful outcome. So let's say rolling a 4 on your 6-sided die is a successful outcome. Then if that's the case, then you're looking, if you roll it 10 times, how many times do you get a 4? That is what you're asking with a binomial distribution. Or it could be the successful outcome is the amount of even numbers you get. So that's if you roll a 2, 4, or a 6. So that's essentially what we use a binomial distribution to model, and looks at whether something is biased or not. And important to note is that we also need to know, because I'll be showing you the formula for working that out in a bit, is we also need to know the probability of failure, which is essentially, the probability of failure plus the probability of success, because either one of them has to happen. Their sum is 1, which basically means certainty. They're guaranteed to happen. So we could say that the probability of failure is 1 minus the probability of success. So that'll be 1 minus P in this case. And that's so I'm going to be showing you a work example next. So in this example, we have a tetrahedral die, which basically means it has 4 sides instead of 6. You'll see why. I didn't want there to be too many different outcomes, because 6 it explodes quite quickly. And in this worked example, I've drew out all the different possible ways you could outcomes you could have when you roll this die 4 times. So that's why we have 4s. S stands for successful outcome and F stands for failure. So in this scenario, we think rolling a 4 is successful. So rolling a 1 or 2 or a 3 is a failure. So you could roll 4s all in a row, SSFS, or you could roll any other number in a row, FFFF. And every other outcome in between, every other permutation to be exact, there's 16 of them. That's what's taken account, and this is the formula for finding the probability of small x is the successful outcome variable what we want, so that's 4 in this case, n is the number of trials. That's also 4 in this case. So actually x is the amount of times we want our successful outcome. So it's 2 in this case. We're asking what's the probability of rolling a 4 2 times. So we're getting 2 successfuls. And p is the probability of having a successful outcome. So I'll just write this down here. P, it will be a fourth because there's 1 in 4 chance of rolling a 4 from a 4-sided die. Therefore, 1 minus P, that's 3/4. That's a failure outcome. And I'll just write n equals 4 and x, lowercase x, equals 2. And here's our formula. So n choose x, that's our combination formula we learned. And then p to the n times 1 minus p to the n minus x. It's quite long. The shortcut's on your calculator. So let's look at all the outcomes. We want the probability of getting a successful outcome of 4 2 times. So basically where there's 2 s's, and that would be, there's 2 s's here, s, s, f, f, f. Just circle that. S, f, s, f, and then s, f, f, s, is 2 s as well. Also on this side we have f, s, f, and then that's f, f, s, s, so this one as well. F, s, f, s, then f, s, s, f. I like to write them out like this. It's nice and ordered. These all start with s, these all start with f. That's all my 16 outcomes. So the 6 out of 16. But you'd put them in. So it's nice. There's 6 different ways that could happen, but you'd put into this formula anyway our numbers, and you get out probability. And if you do that, if you put in, so we recapped ncx. Remember, it's a factorial thing. Raise it to this power and put it all into your calculator. What you'll get is the answer is. I'm just putting it in now. You get 0.2109 is our probability. That's how likely it is we get 2 4s from here. What you could also get is you could also be asked to work out the probability of getting a 4 at least 2 times. And what you do then is you realise probability of getting it no times 0, once 1, twice 2, 3 times 3, or 4 times. That's all your possible outcomes, so they all need to add up to 1. So the probability of getting it at least 2 times is probability of getting it 2 times, 3 times, and 4 times. So it's those 3 added together. You can either work them out individually, where x is 2, 3, or 4, and add them all up, or you could do 1 minus probability that it happens 0 times or once, because they're the remaining probabilities added together. So it depends on what you want to do there. That's called the cumulative binomial, because you're adding things up. As well, there's a calculator. I'll be leaving some questions on at the end for you to have a go through, and there'll be worked answers out in the description if you want to have a go at them and see how well you did. So I'll be doing that for every video from now on. So the questions will appear at the end of the video, and the answers are in the description, and they'll be worked through. So I hope you enjoyed this. If you have any questions, please leave it in the description below, as I'll be finishing off binomial in the next video. There's one last thing I want to go over. So thank you for watching.